So now we're going to move on to section F of arithmetic series. And with the arithmetic series, we have two different formulas in our formula packet under the 1.1. And with arithmetic, these are the two that matter the most. This is the one that you've already used, finding the nth term. And then the sum is what we're going to use next. And there's actually two formulas here. There's this one, and then there's this one. And depending on the given information, it tells you which one to use. So here's our u sub n from the last section that we just did. N tells you the number of terms in your series or sequence. Here's our first term, that u1. And here's the term number, the n. And then d is our common difference. So depending on the information, I have two examples for you guys coming up that will give you when you would use one over the other. But in this one, I would need all of this information to use this formula, whereas this one, all I need is the number of terms, the first term, and then the last term. So first and last. We will come back to this formula packet with the geometric sequence. This is coming up in our next section, and we'll talk more about that, but you guys have used a little bit of this before. That's that general geometric form. So in the next part, here's your section F from arithmetic series. So this is all from the book that you can go through. What I'd like to do is to focus on example 16, where we have two different examples of when we would use these formulas. So the first thing you want to ask yourself is which kind of sequence are you looking at? And I know this is geometric, not only because, or I'm sorry, arithmetic, not only because we're in the arithmetic section, but also because it's only going up by 3. So if it's given that it's arithmetic, I have a common difference of 3, and I know my first term is 4. I don't know my last term because of this dot, 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 but it says it wants to sum up to 50 terms. So I'm going to use my u sub n, n over 2, 2 times the first term, plus n minus 1 times d. So I'm going to do my sum of 50, and then 50 divided by 2, 2 times the first term, which was 4, plus n minus 1, or 50 minus 1, times the common difference, which was 3. When I simplify all this, I get 25 times 8 plus 147, and then I do 25 times 155, and I get the 3,875. So that was using the first term, with these first term with the common difference. Now with this one, not knowing the last term, this one would have been a little bit more difficult. Could we have used that formula? Maybe, but this one was the easiest and most accessible. So now for the next one, what we'll take a look at is using the other equation. So in the other equation, we have Sn equals n over 2 times u1 plus un. And we want to look at what we know. We know that u1 is negative 6. We want to find the common difference, which is 7 each time. And then the last term in this sequence is 141. Now the only problem with this is that we don't have n. So we need to find n before we can apply the formula. So to find n, we're going to use some of the information we already have. So we're going to say that we have u sub n equals u1 plus the common difference times n minus 1, which is our general form for arithmetic. So if I use my un given, 141, my u1, negative 6, plus the common difference times n minus 1, I only have one variable I need to find. So then we'll quickly go through and just solve this simple equation. So 7n equals 154, n equals 22. Now we have enough information to use the formula. So I'm going to say my s sub n equals 22 over 2 times negative 6 plus 141. So then I have 11 times 135, which is 1,485. And that's arithmetic series. So you'll do a practice on this, and then we'll get to geometric series the next class. Thank you.